Friends, welcome back to my channel. I received many comments from my viewers to prepare battery overcharging protection circuit. Or in simple words, it is named battery auto cut circuit. This circuit will disconnect the battery at specific voltage level. We can design the circuit using many techniques. We can use Zener diode and transistor simplest circuit. We can use TL431 voltage reference, or we can use operational amplifier, or we can use comparator. Today I will share the technique using LM358. This is very commercial IC, and we can use this circuit which we are going to design now for different voltage monitoring, because this IC, it can be supplied with 3 volt up to 32 volt. So we can monitor any battery voltage and we can protect the battery. It have 2 operational amplifier inside. We can say it is 2-channel IC. This is pin number 8. Index mark here. This is battery. Positive terminal. If you want to use this circuit to protect 12 volt battery, we will connect directly here. 12 volt, 24 volt, 6 volt, any battery voltage we want to protect it, we can use this one. Pin number 4, ground. This is battery negative terminal. We will connect to ground. Pin 3, that is non-inverting input. Pin 2, that is inverting, and this is output pin. And we will connect a relay here, because we are controlling the charging. This point, this is a relay common point. This point normally open, and this is NC normally closed points. And we will connect relay winding here. This end will connect it to battery positive terminal. When this relay will energize, now we are going to control this relay by means of this circuit. We will use a transistor here. A positive voltage are applied to relay. We will connect transistor collector to drive this relay. We can connect directly, or it is best practice to use 10 ohm or 15 ohm resistance for safety of this transistor. At base, we can use 1 kilo ohm to 4.7 kilo ohm resistance to protect this circuit from sink current. We can use C828, C829, any NPN transistor, 2N2222A. How this circuit will monitor the voltage? We will apply a reference to inverting input. I will use 3.3 volt Zener diode, 3.3 volt. I am selecting 1N4620, or you can use any 3.3 volt diode and 10 kilo ohm resistor here. We will connect this point to pin number 2. We can control any battery above than 3.3 volt, because its minimum voltage level is 3 volt VCC voltage. So it is best practice to use 3.3 volt diode. And here is sense pin, that is non-inverting input. We will use any potentiometer, trim pot. You can use PCB mounted, this one. So this potentiometer can be adjusted as per our requirement, or you can use variable potentiometer, any trim pot, 10 kilo ohm. Or we can use voltage divider network. Using voltage divider formula, we need 3.3 volts, and we will connect this pin number 1 to this transistor, and then we will install feedback resistor. Let's make this circuit. Place this IC on the project board. Pin number 4, ground to the battery negative terminal. Pin number 8 to the battery positive terminal. I will use this boost converter module to simulate the battery, because I don't have a battery, and to have a battery and charge and discharge we need too much time to monitor the battery. We will simulate the battery with using this voltage booster module. So we will adjust the voltage and we will see the response of this circuit. Now we will make this voltage reference. Connect this 10 kilo ohm resistor to positive, and I will use 3.3 volt Zener diode. Anode to the ground side. Cathode will connect it to this resistor as it is here, and we will connect this point to pin number 2. It is pin number 2, and I will use this 10 kilo ohm variable resistor. You can use any trim pot. Yes, now it's good. Battery negative terminal to one end, positive terminal to the second end. Yes, the center slider, the wiper arm, will go to pin number 3. I will use this transistor, NPN transistor. The right side, that is base. Yes, center pin is collector. The left is emitter. Emitter, collector, base. So base is this pin. I will place it here. I will use 15 ohm resistor to the collector pin, and I will connect 4.7 kilo ohm resistor to the base. You can use 1 kilo ohm any resistor, but it is best way to use this resistor, 4.7 kilo ohm resistor, and here I am using 15 ohm resistance. Emitter will be connected to ground. Now we need to connect diode to this relay winding. When the relay will turn off, at that time it will not go in oscillation effect. We will connect this diode here. Positive voltage to the cathode, and this 15 ohm resistance will connect it to this anode, and we will take the parallel jumper to this relay winding. Now we need to connect this base pin to pin number 1. To monitor the activity of this circuit, we can use this LED. If you want to connect, you can use, and I will connect 1 kilo ohm resistance to the cathode of this LED and ground. Now I will use this relay. When you are using battery, you can use 12 volt 10 ampere relay, but this time I am using 3 ampere relay because I am not connecting the battery exactly. So this common will connect it to charger positive. charger ground will connect it to battery negative terminal, but charger positive output will connect it to common of this relay. This is a relay common point. Common is connected with this point, and when this relay will turn on, at that time it will connect common to this point. This positive will connect here. This relay drive, it will reach at this point. Now our circuit is ready. To provide positive feedback, I will connect 1 mega ohm resistor between pin number 3 and 1. This is output. So this positive feedback, 1 mega ohm resistance between pin number 3 and 1. Pin 3 and pin number 1. Yes, now our circuit is ready, and I am simulating using this boost converter module. When you are designing this circuit, we will connect charger positive terminal here, and the normally closed point will go to the battery positive terminal. So current will pass through these two contacts. Now we will adjust the voltage and we will calibrate it. This is common and this is positive. I applied, and this time the circuit is receiving 6.1 volt and battery is now charging. Now I will increase the battery voltage. Now the battery is charging. Suppose that we connected this end to the charger and this is connected to this battery positive terminal. Now the battery is charging and this circuit is still off. We can see when the battery will reach at 9.5 volt, this is disconnecting. So we can increase the battery voltage level. Just only adjust this potentiometer to 0 side, low side, and now we will increase the battery voltage up to our required level. For example, I want to cut it at 13.4 volt. I want to disconnect the circuit at 13.4 volt. Now I will adjust this trim pot. We will listen a click sound and the LED must turn on. Yes, we can see the base drive signal is available and the relay is now turned on. When the relay will turn on, what it will do, as I discussed that our charger is connected at this point. Normally the current is going to this battery terminal, but now it will connect at this point. So it will shift the point. So battery is connected at this terminal. So now battery is disconnected. When the battery will discharge, it will turn on the charging circuit. When the battery will receive charging level, at that time it will disconnect the battery. When the battery voltage will drop, it will turn on the charge. We can see at 10 volt the circuit is off and battery is charging. When the battery will start charging from these 2 points, when the battery is charging and it will reach back again to 13.4, it will turn off. It will disconnect the charger. When the battery level will drop, it will connect the charger again. So it will protect the battery from overcharging. I hope this video is informative. If it is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.